Okay, so let's look at number 17. Number 17, we got 64 on one side. We've got 4 times 4 to the 4x on the right side. So we're putting together all the things that we've done so far. If you recall, yesterday at one point we were combining. When we had like bases on one side, we had to combine those powers. So we have to do that. And then we're adding to it what we looked at today, needing to get the same base. So let's start with combining, since those both are base 4, when we multiply like bases, what do we do with the exponents? Add. Now, that first 4 doesn't have an exponent. We don't see an exponent. What is it understood to be? 1. Okay, be very careful with that. You have to have that 1. Okay, if you do not have 1 plus 4x, if you just put a 4x, you are not going to get the correct answer. Okay, you have to put the 1 plus 4x. Questions about that stuff? Same base, multiplying, add the exponents. Okay, now this just looks like a problem we were doing at the beginning of class today. We have different bases. 4 cubed is 64, so we replace 64 with 4 to the 3rd power. Now we have the same base, so we set the exponents equal. 3 is equal to 1 plus 4x. So subtract 1. 2 is equal to 4x. Divide by 4. 1/2 is x. Now, check it just like we've been checking it. The left side, we know it's supposed to be 64. 4 times 4 raised to the parentheses. 4 times 1/2. 64. So 1/2 is our answer. Checks out. All right, now, up to this point, I've been avoiding all the problems that have fractions in them. We're finally going to tackle a few of these here. So let's look at number 18. So first thing, just like we did in the previous problem, we have 2 base 9s on the same side. We're multiplying them, so let's go ahead and put those together. Since we are multiplying, we add exponents. If we divide, what do we do with those? Subtract. Okay, if you divide, then you subtract. Okay, so but we were adding to, or we were multiplying, so we add. Okay, now we need the same base on both sides. Ignore the fact that it's a fraction for a second. The right side is 81. Is 81 a power of 9? Yes. So we can write this so that it's a power of 9. I'm going to go ahead and combine like terms there on the left side just to save myself some space. 2x plus 2x is 4x. Might as well kill 2 birds with 1 stone, right? Fix that. Okay, 81 is a power of 9. It's 9 squared. However, it's in the denominator. Remember your property of exponents that say if you have a negative exponent, you can make it positive by moving it within a fraction. So if I have 9 to the negative second, I can make that 9 to the positive second if I move it to the denominator, and then 9 squared is 81. So 9 to the negative second is 1 over 81. If you don't believe me, plug it into your calculator. Check it. 9 raised to the negative second power. We get that decimal value. Well, guess what that decimal value is equal to? 1 over 81. Okay? So if it's a fraction like that, look at the number, figure out the power, and it's just a negative exponent. Okay? Now we're back in the boat that we've been in. Same base, set the exponents equal. Solve for the variable. Negative 6 over 4 reduces to negative 3 over 2. Let's check. 9 raised to the parentheses 2 times negative 3 over 2 plus 4 times 9 raised to the 2 times negative 3 over 2. Don't forget that you can make things a little bit easier on yourself when that's a negative, particularly when it's a negative fraction. I could have stored -3/2 as x and just plugged it in here, but that's what my left side equals. My right side is 1/81. They agree. Okay, let's do another fraction one. Number 19. Okay, number 19 is a little bit different than 17 and 18 because we have two bases on the right side, but they're not the same base. They must be the same base before we can put them together. So let's fix that first. 49 is 7 squared. Okay, and it's looking like we have all base 7s here. We do need to fix that left side. That would be 7 to the negative first. 1/7 is 7 to the negative first. Negative exponent, move it to the bottom. That would give you 1/7. We have the same base on the right side. We're multiplying, so we can add those exponents. So 2 times x minus 5 plus x minus 9. Don't forget you got to multiply the 2 times the x minus 5 first. Okay, we got the same base on both sides. Drop it. Set the exponents equal. So we've got -1 is equal to, distribute that 2. We need to combine some like terms there on the right side before we start moving things from side to side. The right side, we've got 2x plus x, that's 3x. -10 minus 9 is -19. Now we can start solving for our variable. -1 plus 19 is 18, is equal to 3x. Divide both sides by 3, and we get 6. Definitely want to check it, particularly since we did so much to this problem. The left side, there's the decimal value of the left side. Let's check the right side. 49 to the 6 minus 5 times 7 raised to the 6 minus 9. Same value for the left side and the right side. So 6 is good. Okay. Anybody have any questions they want to ask before I do one more? Okay, one more. Let's do number 20. Same thing. We have two terms here on the left side. We're multiplying. They don't have the same base, so they need the same base. 1/16 is 4 to the negative second. 4 squared is 16, but it was in the denominator, so it's 4 to the negative second. Now we have the same base, so we can add those exponents. 2x plus -2 is the same as 2x minus 2. Okay, don't let that freak you out. I'm not actually subtracting. It was just a -2, so that's the same difference. Now we've got the same base. We can set the exponents equal. We have variables on both sides. Start by getting it on one side. I'm going to subtract the 2x so that I can keep my variable positive. -2 is equal to 4x plus 18. Subtract the 18, we get -20 is equal to 4x. Divide by 4. -5 is equal to x. Check it. 4 raised to the 2 times -5 times 1/16. That's the left side. Right side, 4 raised to the 6 times -5 plus 18. Weird number, but the same weird number. So -5 is our correct